All right, it's 1 after the hour. Let's get started. Welcome to the January meeting of the OpenZFS leadership meeting. Welcome to the year 2020, which still kind of blows my mind. Let's get started. We have 3 items on the agenda, and then hopefully we'll have time after that if folks have other things they'd like to discuss. So the first question came to me via IRC from somebody whose name was Firesnake. Their question was two-part. When will O.8.3 ship, and will it include the large dnode ZFS diff fix? So Brian, are you on, or somebody else who has more familiarity with the release schedule?
Yes, I'm here. So at the moment, there is an outstanding patch set for 083 in a pull request that has been put together by Tony Hutter, and we're working on testing now. It does include the diff fix, along with a bunch of other patches. It's there for review. The pull request number is 9776 for anyone who wants to take a look at it. If you have a particular fix that's not in there, definitely let us know before we cut the final tag. We'll make sure that it gets included or at least looked at. As for when it gets released, I would say when we wrap up our testing. So we think everything's there that we need. We're just making sure everything works and we get packages built and tested for everything. So soon, I would say.
Right.
And take a look at the pull request.
Cool. So you'd say probably this month?
Yeah, in fact, we want to make sure, it was just commented in the issue a couple of days ago, that we want to get it out sooner rather than later to make sure that it gets pulled into Debian and Ubuntu for the next LTSs,
Yeah.
or at least the next Ubuntu LTS. So yes.
So
apparently their freeze date is, looks like mid-February. But yeah, this month is the target.
Sounds good. Are there any follow-up questions on that? Sorry, Firesnake, I don't know if you're actually on this call or not. Okay. Then I just heard from, the next 2 are about encryption. I just heard from Tom Caputi that he's going to be joining us towards the second half of the meeting. So if there's other stuff, maybe we'll do that first and then come back to these 2 encryption questions, since he might be able to answer them better than I can, at least. I see that Alan is typing a question into the document as we speak. So I'll give you, if you want to go now, go ahead.
Yeah, sure. So during the testing of the Z standard work, we realized a slightly interesting something. If you set the checksum or compression algorithm on a data set to a newer version, or a newer algorithm that isn't included in older versions, but you don't write any blocks to the data set, if you then export that pool and import it on an older version, it will fail the assert of that compression or checksum algorithm is out of range.
Yeah, that sounds right, knowing how the feature flag stuff works there.
Yeah.
So that the assertion that's failing is somewhere where it's looking at the property value, right?
Yeah, and it's saying that it's beyond the range of the enum.
Yeah, that's interesting.
Yeah.
So the way that it works under the hood is that when you set the checksum algorithm property, I don't think it really changes anything on disk.
Correct.
And then when you write a block with that checksum algorithm, then it bumps up.
It goes and activates the feature,
Yeah,
increases the ref count and so on.
Yeah.
So the nice thing about this is that the feature ref count actually tells you like how many data sets have blocks that use this algorithm. And so
it has the really nice side effect that when you destroy the last one that was using it, the feature goes back to enabled instead of active.
Yeah, and that's the case even if like you could imagine bumping the ref count when you set a property, but then like you can change the property to something else later, And then like when you delete the data set, then like you don't know whether you should be decrementing it or not. Certainly we could be more sophisticated about this though. I mean, we could change it so that the ref count is essentially like we add one if the data set contains blocks of this type, which we are doing currently, and you add one if the property is set to the value. So like you might typically have the ref count bumped by 2 for a data set that's using it. But if you unset the property, then or when you change the property, then we would decrement the ref count immediately, but still probably leaving the ref count up by 1 due to the blocks in there. Another workaround would be to change the code that, to change the assertion, right? To say like, oh, yeah, this one's out of range. I'm just going to be like property value equals like unknown or like unrecognized value or something like that, and kind of ignore that. So yeah, I mean,
yeah, because another approach we might consider is even just adding the enums to the next release of 0.8 so that there's less chance of people running into this when 2.0 comes out with Z standard support. So it's not out of the range, but I think maybe fixing the assert might be better. But
yeah, Z standard is the only one that's not in 0.8, right? Like the checksum shot by 12 is in 0.8, I think.
Yeah, basically they had this problem and nobody seemed to really notice when those were added quite a while ago.
Yeah, I mean, it would be pretty, once you set the property, typically if the file system,
you're going to write a block.
You're writing the thing almost immediately. Then that's going to prevent it from being imported. But for sure, this is oversight in the design on my part.
Because I thought I saw an easy way to solve it of basically, like we were talking about with the increasing the ref count a second time, and basically using the property change callback to do it. But that happens after the call to DSL dataset sync. And so it wasn't actually activating the feature.
Maybe, I'm not sure about that. Because does the property change callback happen in syncing context?
No, I don't think so.
Yeah, so like you need to get that, you have to change the ref count in syncing context, I think.
Right, yes.
So, we would have to look at like, however we could hook into the property code in syncing context to do that, which I'm not sure. I'd have to look at it to see how complicated that would be, but it might be straightforward to do that. I think the tricky thing is like what happens when you set a property and then it gets inherited down by a bunch of file systems, right? Like presumably we would want to bump the ref count for everyone that inherits the property, which the change callback, iterates over those. But if that's not happening in syncing context, then we would need some additional way to do that.
Yeah,
it's kind of annoying.
So maybe,
or you could say, it's not that we don't set it for every inherited file system. We just set it like if for every set point essentially, because I mean that would give us the same result. All that we're trying to do is say like if this property is set to Z standard anywhere in the pool, then we need to have this ref count bumped so that you can't import the pool on older systems.
Yeah.
I still think it would be prudent, though. I like the idea of if we're settled on the identifier for the feature, adding it to a point release prior to this, that might head off a lot of trouble. I assume it's like if we don't hit the assert, I assume it's harmless, right? It fails gracefully some other way, or I guess it doesn't fail at all because none of these blocks actually you're going to use.
Well, the problem is like, what happens when you go to write something to that file system that has the property that has check compress equals Z standard, and there's no Z standard support in that interface. Like, do we have to like make it like fall back to some other, like do we make it like fall back to, or do we make it like not compress
it won't,
that would be unexpected.
Or,
yeah. Because yeah, in general, like, the pool wouldn't import if there were any blocks actually written with it. But if the property's set, then yeah, it's a kind of a ticking time bomb.
I think it's better. I mean, bumping the ref count is better, I think. I think like adding it to older releases is kind of it's a stopgap, which might not work that well anyways.
Okay.
But if it does work, I mean, if it does work smoothly, then I'm not opposed to it. Like it's fine, even though it's not a complete solution to the problem.
Is there a verifier and assert in the code? Out of curiosity.
Pretty sure it's an assert.
Yeah. So we could easily find out what happens if you, if you have a production build without assertions on. But I suspect,
which is what most people run, right? So
I suspect that when you try to write a block and you get a syncing context, and you saying like, oh, like please compress this with compression algorithm number. Well, I don't know. I don't even know what would happen because it has to translate the. Well, the property is actually the property value is a number, not a string. So.
Yeah, and there's an array of the functions, and
so it's either going to index off the end of the array and explode, or
I think there's a null at the end.
Yeah, but there's a verify when we go to syncing context, and it would blow up. So we'd have to do some work there to, decide how to handle ones that it doesn't support.
Yes, it is an assert.
Yeah. I mean, I think that making that decision could be pretty tricky, especially with the checksum, because like some checksum, like you might add a new checksum algorithm, which is, a strong checksum algorithm that's like dedupe capable and whatnot, or you might add a new checksum algorithm that's like lightweight and fast, and the behavior, the user observed behavior of those two is very different. So it's like, how do we choose whether we're going to fall back to like checksum equals SHA 256 versus fall back to checksum equals Fletcher 4.
Yep.
So there was a related question about compatibility, like the way the feature flags work. Would it make, I guess maybe not. Is it practical to actually be able to import a pool that has, say, one data set that's compressed with Z standard on, say, a 0.8 system and just not be able to mount or use that one data set?
Yeah, I mean, I think that would be, you'd have to write some code for sure, but I think that doing that would be a nice enhancement to the feature flag system. We would need, it would be hard to do it retroactively because you need to know that this feature flag actually you can import the pool, but like if this feature flag is set that we don't understand, but it has additional flag that says it's okay, you can actually import the pool, but you just can't access specific data sets, and the way you tell which data sets is via this other flag that we have on the data set.
Note that dedupe makes that even more complicated and possibly not doable.
Dedupe?
Yeah, because with dedupe you can have blocks shared across data sets.
Yeah, I mean, yeah. So like if you, well, I don't think that.
Yeah, that means you can have a block that is compressed with, for example, ZSTD that is shared among 3 different data sets.
Yeah, and all 3 of them would have the flag set, so you wouldn't be able to modify any of those 3.
Right.
And if you wrote any new blocks, they would not be compressed with Z standard, and therefore they wouldn't be able to dedupe against those anyways.
But you could accidentally poison certain data sets, right? And make them get the reference count set accidentally just by happening to write a block that dedupes. Right? You couldn't intentionally exclude one to say this one should never get the Z standard feature enabled because it's my root data set or whatever, and I never want this to happen.
All right. Well, yeah, I'm thinking we probably need to think harder about that. about
Yeah,
that.
I was just thinking of the concept we already have of read-only compatible flags.
Yeah.
And I'm just kind of like, this feature only affects the data sets that are poisoned with it, not the whole pool.
Yeah.
Yeah, that would be really cool.
Oh. Yeah.
Because like you said, that might make a big difference for example, being able to boot off of a pool that's using Z standard, even if your bootloader doesn't understand it.
Yeah, for sure. That would be nice.
Yeah.
Cool. Other questions or comments on this topic before we move on? All right. Tom said that he has joined the meeting, so let's come back to these encryption ones. It looks like there's even a third encryption question on here. So, Richard Lager, are you on? Do you want to talk about the Ubuntu proposal with like enabling encryption by default?
Sure, yes. So I'm sharing this primarily because anything that Ubuntu does with regard to ZFS support is high profile. There isn't necessarily an action item here. So I'm really just soliciting if there's any additional feedback that I haven't already provided them. Mm-hmm. So because ZFS encryption must be enabled at dataset creation, an Ubuntu developer has proposed that their installer should always enable encryption using a fixed known passphrase. I believe in the example, it's like Ubuntu ZFS. The value doesn't matter. The key part is it's just a fixed known passphrase. The idea is that a user can then later use ZFS change key to set their real passphrase. The idea being it would allow them to opt into encryption later. I assume their long-term plan is to actually prompt for a real passphrase in the installer, like they do for Lux. So I assume this is some combination of a stopgap proposal until that is fully implemented, and or a proposal of how to handle users who do not enable encryption. I've made some specific proposals about how they might do the installer UI, and I think that should be their priority personally. But regarding security, which is really, I think, the important thing here, I had some concerns with this. As I understand it, the master key is stored on disk, wrapped with the user key, which in this case is derived from the passphrase. The user key is thus known. So when the key is changed, when the user key is changed, the old wrapped master key will still be present on disk. Therefore, it seems to me that an attacker with access to the disk can read the old wrapped master key, decrypt it using the known passphrase, then decrypt the whole pool, including newly written data, because the master key doesn't change. I discussed this with Tom a bit. An area for future ZFS development might be to overwrite the wrapped master key on disk when it is changed. That may be a good idea, independent of whether or not Ubuntu, does this. I guess I've already shared my concerns with them about that. If anyone has any additional thoughts, I'm happy to pass those along, or you may wish to comment directly on the bug report, which I have linked in the document.
Right, and just to elaborate on that a little bit. So back when we were writing encryption, and we kind of knew that trim was coming at some point in the future, but it wasn't quite around yet. We'd actually thought about this problem, and what we had said was when trim gets added, it will be easy to do things like secure erase. And we just never really revisited that. So I think this is just, or I think in terms of like making a solution, because what the general proposal for that kind of UI is not altogether unreasonable or anything. It's just kind of not, from a very strict security standpoint, this is kind of not the way, this won't really work without being able to like kind of zero out or securely erase the old encryption key. So I think, at least from our perspective, versus the Ubuntu, regardless of what Ubuntu does, I think this is just something where we should take the time and go through and figure out how we want to implement secure erase specifically for encryption key.
What happens there in the presence of a Z-pool checkpoint or like extreme rewind?
So in the case of a Z-pool checkpoint, and this is like one of the things that we need to figure out, those definitely would kind of go back in time. We don't really have a way to prevent that, because if we, like, from a security standpoint, if you have a checkpoint, you know, we need to allow the user to be able to go back that far. And, you know, so if we delete the encrypt, so the key needs to live on the disk somewhere. You know, even if we decide to have some special mechanism for it, it's really kind of the same thing from a security perspective, because the key still needs to live somewhere on disk, wrapped by the old password, or, you know, wrapping key in general terms. As far as checkpoint is concerned, maybe we just need to have some kind of documentation. Like there are already some warnings in the ZFS man page for you know things that encryption will and won't protect you against, some little caveats and things like that. So adding this, you know, once we add some kind of you know, secure erase feature for the encryption keys, that's definitely something that we should add to the doc. But I don't think there's any way around that.
Right. And probably even maybe a warning when you do a rekey if a checkpoint exists, being like, hey, make sure you realize.
Yeah, exactly. I think, but I think at the end of the day, that's got to be more a matter of documentation than a technical solution, because there's no technical way to make that work. Right. In terms of extreme rewind, I mean, there's some random stuff we could kind of do there, but that would be kind of hacky. Like, you know, we could just. But again, I think I think in general the correct solution there is going to be more a matter of documentation than anything else, because like it will probably also take a little bit of, you know, us making a decision in terms of when you delete a key, or, you know, rather when you choose a new passphrase. Should we secure erase it immediately? We could set up some kind of mechanism to do a deferred deletion, but that adds all kinds of random complications where, you know, you thought you were secure and now you're not. So personally, what I'd probably advocate for is just, you know, rewrapping the key immediately, and then, it's rewrapping the key immediately and then kind of not, you know, like, you know, and then extreme rewind won't work, but I think extreme rewind is a fairly niche use case kind of thing.
Right, and it's only going to work for a couple seconds after anyway.
Exactly, and it's the kind of thing where it's very much a desperation thing, whereas this is more of like a general integrity of the file system thing. That's kind of my personal opinion right now, but you know, we could definitely talk about it or anything like that. But those are just my current thoughts at the moment.
So I'll preface this by saying that I'm not an encryption or security expert, but the security aspects
Nobody is.
Seem okay. The security aspects of this seem very questionable to me. Even with secure erase, like you know, if somebody has access to the disk before they change the key, then they can get the you know, the key that's wrapped. They can get the master key that's wrapped with a known user key, and then, you know, access. Then your encryption is worthless, right? Regardless of changing the key or whatever. To me, it seems like and I think that relying on trim is like, I don't think we should rely on trim. It helps, but we can't be like, we don't really know what happens in the hardware when we issue the trims. We don't really know what happens in the hardware when we issue writes either. So like, we could issue a bunch of trims, and like if it's on an HDD, then those will be ignored. We could issue writes instead of trims, but like, we still don't know what's really happening in the hardware. Like, we don't know if the hardware has like remapped some block and there's some way to like access the old mapping, or like what, you know, it's it seems very questionable for us to be saying that, oh, like, don't worry, we trimmed everything, so now there's no way for them to get your old key, right? Or even we've overwritten everything, and so there's no way for them to get your old key. Like, I don't think that's a good idea. I think that we should, I would prefer to work with the Ubuntu folks to understand like what problem they're trying to solve here, because you know, there's if the problem that they're trying to solve is like the user might want to encrypt their own data after installation without setting it up at install time, then it would be easier to just like create a new file system for the user's data with encryption, or like take the file system that has the user's data, do a send and receive to a new one that has encryption, and then delete the old one. Or barring something like that, maybe we go down. I think the closest thing to what they're proposing that might be like security-wise reasonable would be to say that like we'll change the master key, so that at least like all the stuff that's written with the old user key can be read with the old user key that everybody knows, and stuff that's written after that has the new key and has the new master key, and people can't read that. I think that is like it's tricky to explain exactly what that means, because like how do we tell them what is the old data and what's the new data? Like after you've done this, you don't really have any visibility into what data is secure and what data is not secure, which is I think why Tom chose originally to not let you change the take an existing data set and say now encryption equals on this thing and new stuff will be encrypted, because it's hard to understand what's secure and what's not secure in that scenario. And you get into a similar situation here if we say like, great, we'll just change the master key from one that everybody knows to one that people don't know. But that is, I think, probably better than a bunch of the other proposals. Another point, I think that another point against having a known user key ever is that you could imagine use cases where like you install some Ubuntu machine and it has the known key, and then you're going to rely on this mechanism that changes the key later on, or changes the user key later on. But you take this Ubuntu system and you like make a bunch of copies of it. So now like your whole fleet of machines is using the same master key, which now anybody can, like I get one of these machines and now I know the master key that's for all of the machines. So even if you change the user key, like it's not just this machine that I can read, it's like every machine that was a clone of that, because they all have the exact same identical master key. Even if that's not kind of the intended use case, it seems like a really rough kind of gotcha that we're leaving, that would be kind of left in there as part of the design, because they have this known user key. So you have to be careful to avoid that use case, which people would. This is designed for kind of naive users, I assume, and so like adding this additional requirement on top of like naive users' use cases is, they aren't going to get that security bulletin.
So I did want to respond to a couple of the points, and I'm sorry, I was trying to keep track, and
yeah, sorry, I kind of.
No, it's fine. You just made a lot of points, and I was trying to keep track of some of them, and so I might have forgotten some. One of the things I did want to say is regarding the. I have a different opinion regarding the idea of trimming the stuff, and basically, so the idea of that was not that we are issuing trim commands. The idea of that was that previously, before VDEV initialized, at least in ZFS, as far as I'm aware, we didn't really have a way to zero out free data, and so I wasn't. The idea there wasn't to use like a trim command. It was to use that existing to use this idea of being able to write data to free blocks in the file system that didn't exist at that time.
You do like initialize rather than a trim, so that you're doing writes rather than
right.
trim. Yeah.
Right. So, and also instead of trim, like the actual trim command, there's a different one, at least in Linux. I'm not really 100% sure about the other operating systems, but in Linux they have a different command called secure erase, which is kind of advertised for this purpose of, I want to overwrite the old data. Now, you brought up the point that we don't really know what the hardware is doing, and that is 100% true. We don't know what kind of remapping is happening under the hood. We don't know, we don't know if somebody gets out a soldering iron and gets into the firmware of the actual hard drive, what they might be able to find. But at the same time, we can't, as a file system, we do trust the hard drive to do what we tell it to, at least a fair bit, at least with regards to sync and and things like that. And I think the main idea here shouldn't be, it shouldn't be that we're not 100% sure that this will work all of the time. Therefore, we don't want to make any promises. I think personally, the way I'd like to look at it is more, we are not, we have issued the command and done the best we could to make sure that this key won't be rediscoverable. And whether or not that's actually good enough could depend on your hardware, and how they've decided to implement some of these, kinds of ideas. But the idea, at least from my perspective, is that we should at least do our best to clean up after ourselves wherever we can, from that perspective. Sorry, did somebody have?
Yeah, I thought you were done talking.
I'm sorry, I was trying to respond to that. Did make a bunch of points. You said that. Sorry, I was midway through. I started to write stuff down, and I was not very good at it. The other thing that I want to point out is, or that I wanted to kind of express is the idea of, so you mentioned that if everybody gets a known password, then then that can have then anybody who can find that old password, or who knows that old password and can find the old wrapped master encryption key, then obviously that's a security problem, and whoever can do that will definitely be able to find and do terrible things. But from the same perspective, we do have, for instance, key changing in ZFS, so that if you don't like your password anymore for whatever reason, you can change your password. If one of the reasons for that is if somebody compromised your old password, so that somebody out there knows your old password, and we still allow you to change your password and get some kind of at least feeling of safety there. And I think we should do, again, with as much power as we possibly can. I think we should try to uphold that, because I'm sorry, go ahead.
So I do kind of agree with you there. In that case, we are not changing the master key, though. Is it correct that we're not changing the master key, and therefore, if your old password is compromised, then even after changing the password, somebody can compromise the newly written blocks? Is that the case?
Assuming that they can find the old, that they can find the master key either by remembering it from from when they knew the password and storing that themselves in memory, or by knowing the old passphrase and finding the old wrapped encryption key and then re-decrypting that from the free data of the file system. Yes.
Would it be reasonable for us to change the master key when they change the wrapping key, so that we could at least say that newly written data won't be vulnerable to people that know the old passphrase?
The problem is that So one of the things that I kind of wanted to avoid when we originally set out to do this, there are 2 points there. One of the things is that one of the things I wanted to avoid was the idea that your data is partially protected, if that makes sense.
Mm-hmm.
So like if you have an encrypted data set, I kind of wanted that to be same thing with the why you have to choose encryption at creation time, because theoretically we definitely could have made it so that your data is was not encrypted and then you turned encryption on and then it's encrypted, but then you'd have no visibility into what data is protected, and with or if you change the algorithm and then one of those algorithms had a security problem. So that's kind of why we made the decision to do that. In terms of changing the master key, I do not believe, and I'd need to go through it and try to figure something out, like and give it some honest thought. But I believe I've worked through this before, and I don't think that that's really possible to do, because no matter what, you need to be able to decrypt your old master key.
So you need track of the old master key and the new master key, and which the timeline basically.
Yeah, I think it'd be kind of similar to the time variable geometry stuff we had looked at for A shift, right? Where we'd have to know everything written after this transaction group is using this key, and after this one is that other key.
Yep.
Mm-hmm.
Yeah.
It would, at minimum, without having put too much previous thought into it, at minimum, it would be kind of like a matter we might be able to do something by creating a completely separate object that's encrypted, completely separate or completely new entries in the zap in the same zap with the new master key. Yeah. But then you end up with all kinds of issues like, how do we locate which master key to use? What if you keep doing this command over and over again because you don't realize what you're doing, and you just see master key rotation and you decide to do that over and over again, and now all of a sudden, like, we have to search through all of your old master keys to find the one that you actually need for this block.
Yeah.
So there are some issues there.
Yeah. So kind of setting aside the implementation for the moment, it sounds like it's possible, but not like easy necessarily. I'm
going to say probably, with it again without having given it.
Yeah, it's probably possible, but not easy. It seems like the current design, it kind of gives you the worst of both worlds, because you're saying like, no, you can't change the master key because I don't want to give you data that's like partially protected, but I'll let you change the user key. But like what that means is essentially like anybody who has any of the user keys can access all of the data. So it's like, I think saying that you can change it, saying like, we want to handle this use case of your key was compromised, so you can change the key, therefore we let you change the user key. But actually it doesn't give you any protection, because the old user key is still valid for, for accessing it, assuming that you can get the, a copy of the old wrapped key. Like that seems a little bit, it almost seems like we're giving the user the appearance of security where there isn't, which exists.
I don't know that any other disk encryption system works differently than that, though.
My one counter argument to that, and I'm sorry for interrupting, but my one counter argument to that is, if at one point in the past you had the user's key and you got into the system, like you could you have everything you need at that point to get to a master key, right? So as soon as you have a master key, like any amount of changing the user key or doing anything like that all of a sudden doesn't matter anymore.
Why is that? Like if like, let's say they get the master key.
Or I'm sorry, any amount of changing the wrapping key doesn't matter anymore, right?
Yeah.
But the only way to deal with that, the only way for you to get back to the point where your data is protected again, is to re-encrypt all of the data, like by doing some kind of send or receive. But at the same time, if we are assuming that whoever has done this attack has both, has already gotten this far, then kind of your data is probably, by that extension, your data could already have been compromised anyway.
Yeah.
So I don't know, like this is one of those kind of things where, and I'm sorry, I do have to go pretty soon, like in the next 3 minutes or so. But this is kind of one of those things where, like if we were gonna, I'm not sure how absolutely secure, you know, we can make this, because at the end of the day, like the only, we can protect against more and more kinds of attacks, but at the end of the day, the only way to really make sure that your data is secure is to not have it written down anywhere, which, you know, that's that sounds very defeatist, I guess. I realized when I said it, but I don't mean it to say it. I don't mean to say it like that. But what I mean is that, like, if the encryption implementation is going to be kind of at all usable, like there's always a balance between usability and security, and you know, we need to figure out what that is. But I'm not 100% sure we will always be able to combat every level of attack like this. Or every level of attack like this. I'm not sure that preventing all of these kinds of attack necessarily makes sense, because at some level, if you get to one of these attacks, you already have won, if that makes sense.
Yeah.
Like I know I said that very poorly, but like
No,
if you can get to some of these attacks, you've already kind of gotten everything you want.
Like, in other words, I think what you're kind of saying is that if the attacker figures out your passphrase, or figures out, you know, any passphrase that you've used in the past, then they've already won. I think that's a valid point.
If they did that and they have access to your disk.
Yeah, yeah. Which, like, is the kind of the point of encryption, is to protect you if they have access to your disk. If they don't have access to your disk, you don't need encryption at all.
Right.
You know, I agree with what you're saying. My point, I guess, is that like, let's not give the users the false idea that changing your passphrase actually does anything. Like, changing your passphrase is for, like, I don't like typing that old thing anymore, I want to type some new thing. Not for, somebody knows my old passphrase, let me change it to one that people don't know. You know what I mean? And therefore, like, if that's kind of what we're saying, then this proposal by Ubuntu of having a known passphrase, like, doesn't make any sense, right?
Mm-hmm. I do have to head out, but could we talk about this a little bit more offline? And because I think we definitely, at the very minimum, we have some thinking to do here.
Okay.
You know.
I have a quick question related to this. This is just a dumb, stupid, making sure everyone's on the same page question, which is when you change your password, the old instance of the wrapping key is not deleted or overwritten.
It is
deleted.
It is deleted. The issue is that at the time that encryption was implemented, there was no way to overwrite it. So it was in the free space of the file system, and that could get used for new data or not. But as of right now, it is not actually overwritten with.
Okay, so that part could change. Okay, please go. We can deal with further discussions later. That was just trying to make sure everyone's in sync.
Yeah.
Sorry, I had to leave kind of early, but thanks very much.
So yeah, I think we'll need to follow up with that more. By the way, is there anybody from Canonical on this call? All right, I guess not. We'll make sure to follow up with them on their bug tracker, and kind of once we come to some sort of conclusion as to what we want to recommend to them. Obviously, with the knowledge that, like, you know, Canonical can do what they want, but we can give them the best advice that we can.
There are 2 people from Ubuntu, but apparently they're in a noisy environment and can't speak.
Okay, that's fine. Well, if the folks from Ubuntu have advice on just kind of who we should be talking to, or, you know, what forum we should be having that communication. If it's something other than the Launchpad bug tracker that's linked there, then just let us know. Great to see. All right, you're welcome. So why don't we move on? We only have about 15 minutes left, so let's move on to the next encryption-related topic, which hopefully will be at least simpler, if not less controversial. Richard, do you want to talk about why the proposal to change the default from CCM to GCM?
Right. So I'll cover this, I guess, a little bit briefly. Before we can take any action, I think we'd want to make sure that, Tom has a chance to review it and comment and so forth. But basically, currently, encryption on means AES 256 CCM. My proposal is that we change that to AES 256 GCM. In my view, there are two main factors to consider: security and performance. I'm not an encryption expert, so I can't make a rigorous argument, but I will say that GCM is widely used these days. It's the
I can make an argument against it.
Okay.
GCM. Okay.
Okay, if you like me to. Basically, CCM is great in small quantities, but in order to do any verification of it, you have to decrypt the entire thing first and then compute your hash. Whereas with GCM, you compute the hash based on the encrypted data set. This means that you can have larger values, larger encrypted streams, and get better performance just when even when trying to verify. But with CCM, when you go to decrypt, you have to decrypt the entire block, compute the hash, and then decide whether it's okay or not. And then you have to do this in a way such that there are no unencrypted bits left over in case of failure. So you then have to decrypt again. CCM is a horrible algorithm. We should not use it.
Okay. Yeah, so there's, I guess, an argument in favor of the change. I guess the other things I was going to point out is it's the best practice to use GCM in TLS these days, according to sources like Mozilla. OpenSSL supports both modes for TLS 1.3, but only enables GCM by default. So I think that's more evidence that GCM is the way to go. Really, the other argument here is about performance. So GCM should be faster in theory, from my understanding. That seems to hold true in practice. On pull request 9749, just one random test showed that GCM and ZFS was about 15% faster than CCM. That's before the changes in that pull request, which improved GCM performance on modern Intel processors by 12 times. So that speed up comes from porting the assembler routines from OpenSSL. And the author said that if the CCM routines were also ported, which they are not in that PR, GCM would still be 3 to 4 times faster. So in general, it feels like in 2020 that GCM is both more secure and significantly faster. And I guess that's the impetus for me suggesting that it should be the default instead of CCM.
I said a while ago it should be the default instead of CCM. So you've got my support for this.
Yeah, I mean, sounds fine to me, but again, I'm not an encryption expert, so we'll make sure to get Tom's input, but it sounds great. I mean, performance is good.
Yeah, sounds good to me for all the reasons we mentioned, but same caveat, I'm not an expert.
Cool.
Okay, thanks.
We only have a little bit of time left, and I see that Christian, you added 2 items here. Would you mind if we, the first one about the IV set GUID check seems a little complicated to explain, and also I think that's, Tom is probably the expert for that. Would you mind if we skip that and put that for next time, and then cover the bookmark cloning one in the remaining few minutes?
Yep, although both points are very brief. So I'll start with bookmark cloning one, and then let's see how far we can get. I think the other points were already addressed. They are just in the wrong order in the agenda notes. Okay, so the bookmark cloning PR, I implemented bookmark cloning and support for channel programs to create bookmarks. There is a work in progress PR open on GitHub because there is one remaining design issue to be solved. I if you click on the link in the like indented enumeration item, you will see that there is a fix me comment in the document, and that is about what should we do when we clone a redaction bookmark. So bookmark cloning in general is, I think, fairly straightforward. Like you have a bookmark already and you want a second bookmark that has the same contents, then you just run the bookmark command with the bookmark as a target instead of a snapshot as a target. So from a user perspective, it's very simple. The problem is, what do we do if the target, if the thing that we are cloning is in fact a redaction bookmark, because the redaction bookmark has a huge amount of data attached to it in the redaction object, and I don't really know what to do here. Like at the moment, I error out and don't support cloning redaction bookmarks, but that might break user experience or something. I don't know. So I'd be happy for any input on that.
Yeah.
Or questions about the feature.
That makes sense to me. Paul, do you have any thoughts or kind of preferred way of doing that?
When it comes to cloning the redaction list, I mean, we can try to just do a reference count style thing, but redaction lists, generally speaking, aren't that large. I feel like just having a second copy of the list is not going to be that big of an expense.
Yeah, I kind of agree. Like the redaction list, there's probably a bunch of things that kind of assume that it's not super huge. We're probably talking, in the biggest cases that we've
a couple megabytes
seen in practice, yeah, like a couple megabytes.
Yeah, no, it's never going to be that huge.
Which is not like, I mean, it's not just one block, but like copying. The issue is, I guess maybe the real issue is not space usage, but like copying that whole thing in one TXG, in one sync task.
Yeah, that's true.
When we're creating it, we write it over multiple TXGs, but
correct.
The main reason for that is that like computing,
you can have to read an arbitrary amount of metadata between each write.
Yeah, exactly. Like we have to go read huge amounts of metadata potentially in indirect blocks, but then we're writing this much more compact data structure.
Right.
All right, so I wasn't aware that the size is actually that small, but I only have a very rudimentary understanding about the redaction feature. So, okay.
Yeah, I mean, I think that you can make arguments either way. Like for practical use cases, I think probably just copying it into one TXG would be fine. On the other hand, like you probably could create some artificial use case where like you can make it arbitrarily large. Because it's, Paul, remind me, is it a list of blocks or is it ranges?
It's ranges, but that just means that, if your file is like a sparse file where like 1 out of every 8 blocks is filled and every single one is redacted, you can have an arbitrarily large redaction list.
Yeah, so like if you create a big file and then you like overwrite every other, in the clone, you overwrite every other block, then you would end up, then you could create a large redaction list.
And it's 32 bytes per block that you redact.
Yeah.
I mean, it compresses, which will remove a lot of this, but.
Yeah, but it's still kind of, you have to like read that stuff in, decompress it, copy it, and write it back out again.
Yeah.
So there's a whole other angle to that, and that's from the user experience or user expectation point perspective, because you do the bookmark cloning by running ZFS bookmark, and at the moment ZFS bookmark always creates a lightweight bookmark, like a V1 or like a V2 style bookmark probably at this point.
Yeah, it's true. You don't create redaction bookmarks by running ZFS bookmark.
You do with ZFS redact.
Right.
So I mean, I guess that point, your argument is like, maybe we don't need to support cloning redaction bookmarks at all. Is that
at least like I think like I have I got this far, but right now I have no idea how to like properly do the object copying in this syncing context. Like I didn't find code that does something similar, so I couldn't find myself around in the code base. And keep in mind, like this is all hobbyist work. So the second bullet point on the to-do list is I need some review on this.
I think that at least a valid preliminary implementation would be that like you can pass in a redaction bookmark to copy, but it just won't it won't attempt to copy the redaction list. It'll just create a new bookmark with the same like birth TXT and written stuff, and it just won't it'll just set the redaction op to 0, so it isn't a redaction bookmark. But like the command line utility would warn you before you allowing you to do that, where it's like, hey, this is a redaction bookmark. Copies of redaction bookmarks are not redaction bookmarks, at least as currently implemented.
Okay, so you would opt for like you have to you cannot bookmark clone a redaction bookmark by default, but if you specify a flag like -- I know what I'm doing, whatever, then you can actually bookmark a redaction bookmark, but without the redaction object and without the
right. And so later we could go back and bookmark. If we feel like it would be useful, we can implement cloning the actual redaction object.
Yeah. Okay. So, but the default should be to.
This is one proposal. Other people may have other feelings about it. But
Yeah, seeing the user interface now, which is like you're running ZFS bookmark. So like you're running ZFS bookmark target name of new bookmark. Today, like that creates a new bookmark that references the time of the target, where today the target is always a snapshot. Obviously, the bookmark is not a copy of the snapshot. It's just telling you the time that the snapshot was created. So I think that it's a valid argument to say like, well, now the target can be another bookmark.
And it's just referencing the time. It's not referencing the redaction list.
Yeah, and again, like we aren't copying the bookmark. We're creating a new bookmark at the same time as the target.
That's also a valid argument. If that's the approach we choose to go with, we should just make it very clear on the man page.
Yeah.
That, like, we are creating a new bookmark that references the time of this bookmark. It does not reference other properties like redaction lists.
Yeah. So like, I think that that going that way kind of makes sense to me. The like phrasing of bookmark cloning, I think, runs a little counter to that. But that is, I think, only the title of the pull request and not actually, anything about the actual change. So, if we just call it more clearly, like you can create a bookmark from another bookmark in the documentation, and don't use the term like cloning or whatever, then I think that it could be just fine to do that, to just say we don't copy the redaction info. We're just creating a new simple bookmark at that time.
Yeah, I'm not a native speaker, so if anyone has a proper verb for that, because I am a fan of proper naming of things. So yeah, please come forward.
Okay. Well, I think we're about out of time on this, but does anybody are there any last thoughts or opinions on the proposal of saying that you can, when you create a new bookmark from a redaction bookmark, then it does not copy the redaction info? Okay, then I think that sounds like a reasonable way forward with your pull request. And yes, I got them. I think Paul and I at least need to take a look at your code review as well.
All right, thank you.
Cool. Thanks for implementing this, Christian, and thanks for driving it forward and bringing up the outstanding issues at the meeting.
Oh, maybe one last question. Should I separate out the channel program support into separate pull requests, or should it be the same pull request? The channel program support builds on top of the bookmark cloning feature. It would be hard to split them up into two. They are separate commits, but
I think having them just be one pull request and even just one commit is fine. I mean, I think we want to go more in the direction of the channel program stuff being first class stuff that ideally we would like to see included, when when new features are implemented. So I think that's great, and just including it as one is fine.
Okay, thank you.
Cool. So sorry that we did not get to everything today. The encryption discussion was very interesting, and I look forward to continuing that. I think we got good input from everyone, and to be clear, I don't think that I necessarily have the one right answer on that encryption stuff. So I definitely look to other folks for continued input and discussion on kind of what both should we be implementing something different than what we have, and how should we be describing it to end users, and what we should be recommending to Ubuntu. Cool. Thanks, everyone. The next meeting will be, I think, 4 weeks from today, February 4th, and it will be at the later time, 1 p.m. Pacific. Thanks. Yeah.
Thanks, Matt.
Thanks.